Welcome to the Explainer. Today, let's break down how to build your digital headquarters in Microsoft Azure. So, how do you build a business in the cloud? It's a lot like building a real HQ. It all starts with a plan. First up, you need a solid blueprint. This is what's going to keep everything organized before you even start building. In Azure, that framework is a simple hierarchy. It keeps all your digital stuff tidy and manageable. Right at the top, you have management groups. They're basically overseeing your entire organization structure. Underneath those, you have subscriptions. They're kind of like different departments, each with its own budget and rules. And at the bottom, resource groups. These are basically folders that hold all the moving parts for each project. Okay, your blueprint's ready. Now it's time to actually pick out your building materials. So the rooms of your HQ, those are virtual machines, or VMs. They're the servers doing all the work. And you get to pick the right kind of VM, whether you need more processing power or just a ton of memory. And what about filing cabinets? Well, in Azure, that's your storage account, and it's massively scalable. And you've got options for everything, from basic file storage all the way to complex databases. All right, so your HQ is built. Now, how do you keep it safe and running around the clock? You need high availability, right? Azure does this with availability zones, separate data centers to prevent downtime. Okay, but what about security? Well, it's a partnership, a shared responsibility between you and Microsoft. This shared responsibility model lays it all out, clearly dividing up who handles which security tasks. So Microsoft secures the physical cloud, and you secure your own data and who can actually access it. Tools like Azure Bastion are great for this. You can connect securely without exposing your systems online. So your digital HQ's up and running. Now let's talk about managing the bills and handling growth. You can either scale up by making your machines more powerful, or scale out by just adding more of them. But let's be real, the biggest question is always this: how do you control the costs? Well, planning ahead with things like reservations and using existing licenses can save you a ton of money. So you have the blueprint, you have the tools. Now the only real question is, what are you going to build?
Welcome back to the deep dive. If you are serious about advancing your career in the cloud, you know the AZ-104, the Microsoft Azure Administrator Certification, is absolutely critical. But this isn't just another test.
That's absolutely right. Our mission today is to create a true blueprint for passing this exam, but, more importantly, a blueprint for success as an Azure administrator in the real world.
Yeah.
This certification fundamentally tests your administrative competence. We are not just summarizing what's on the syllabus, we are helping you internalize what we call the Azure doer's mindset.
We've compiled the most effective strategies and technical breakdowns covering the 5 core domains that structure this test.
Yeah.
We need to move beyond seeing Azure as just a collection of individual services.
Yeah.
Our goal is to connect identity, networking, storage, compute, and governance so that you see them as one cohesive, resilient, and, cost-effective architecture.
The foundational hurdle of AZ-104 is adopting the perspective of an architect who solves complex business problems, rather than just a technician who follows click-by-click instructions.
Right.
If you grasp the subtle interplay between, say, a network security group and an application gateway, and understand the why behind choosing a specific redundancy option, you have mastered the material, not just memorized it.
Let's unpack the strategy by starting with the exam itself.
Yeah.
Knowing the official domain weightings is key to allocating your study time effectively, right? Making sure you aren't spending 40% of your time on the 10% section.
Based on the 2025 stability reports, the weightings are crystal clear, and they really emphasize core administrative duties. You have 2 massive pillars: manage Azure identities and governance, and deploy and manage Azure compute resources.
And those are both clocking in around 20 to 25%.
Both clocking in around 20–25%. These are your heavy hitters.
Okay, so those are the big ones. What about the rest?
The rest are critical support structures. You have implement and manage storage, and implement and manage virtual networking at 15–20% each.
Right.
And finally, monitor and maintain Azure resources rounds it out at about 10–15%.
Okay.
Now, let's talk about the specific mindset required for each. When we look at that top domain, identity and governance at 20–25%, the concepts of zero trust and least privilege must define your thinking.
Zero trust means never implicitly trusting any user or service, even if it's inside your network perimeter.
Exact.
And least privilege means giving an identity only the exact permissions it needs for a task and nothing more.
Exactly. The question isn't, how do I create an Entra ID user? The real test is, how do I structure a custom Azure role-based access control, an RBAC role, so that a junior developer can only restart a specific virtual machine within a resource group tagged DevTest?
But they can't touch anything else.
But they cannot modify the networking configuration or delete the storage account. This demands a precise understanding of RBAC scope and action definitions.
Okay, that makes sense. So, moving to implement and manage storage, the 15-20% one. You mentioned it earlier, but it's that balancing act, right? Cost, performance, and redundancy.
This is where administrators save or waste massive amounts of money. You have to master the redundancy options, LRS, ZRS, GRS, GZRS, and really understand the financial implication of each choice.
So like if a source file is easily recreated, temporary log files or something?
LRS is fine, but if you're storing mission-critical financial records, you have to be able to justify the expense of RAGZRS. You are balancing 11 nines of durability against the monthly bill.
Then there's deploy and manage Azure Compute Resources, the other big one at 20-25%. This domain is dominated by ensuring scalability and resiliency.
This tests your ability to design for failure and volatility. When a hardware rack dies, does your application survive? That's availability sets.
Yeah.
When an entire data center goes offline due to a tower outage, does your application survive? That's availability zones. And when traffic suddenly triples during a holiday sale, can your infrastructure automatically scale out to meet the demand using VM scale sets? You need to answer all three questions by deploying the correct foundational compute elements.
Our fourth pillar, implement and manage virtual networking, around 15-20%, is the secure backbone of everything. It has to be.
It absolutely is. This is where we define connectivity and isolation. And the core tool here is the Network Security Group, the NSG.
Okay.
You need to move beyond thinking of it as a simple firewall. It's a stateful layer 4 filtering mechanism based on the 5-tuple source IP, destination IP, source port, destination port protocol.
And the trick is applying it correctly.
Yes, the administrative challenge is applying it correctly, either at the subnet level for broad isolation or the NIC level for specific VM rules, and making sure the priority rules work as you intend.
And finally, the smallest domain by weight, monitor and maintain Azure resources, which is really about transforming from a reactive troubleshooter to a proactive problem solver.
If the CPU spike is hitting 90%, you don't want to wait for the support ticket that says, our service crashed.
Right, you want to get ahead of it.
You need to leverage Azure Monitor to set up metric-based alerts, integrate those alerts into an action group to notify your team via email or SMS, and then use log analytics queries to investigate the root cause before the issue becomes visible to customers. This whole domain is about anticipation and automation.
So knowing these domains, how do we shift the mindset? Our preparation materials stress 3 core principles that bridge that gap between textbook knowledge and real-world administrative success.
Principle number 1 is the most important. Connect, don't memorize. The exam is full of case studies that require integration. You just can't learn services in a vacuum.
Let's use that classic scenario. Deploying a standard 2-tier web application, a front-end web server, and a back-end database server. If you just memorize features, you create 2 VMs and hope for the best.
Right.
But an administrator connects the services deliberately.
Absolutely. The administrator starts with a virtual network, a VNet. Then they immediately segment it, creating dedicated subnets, a secure, isolated DB subnet, and a web subnet.
That's step 1, the logical segmentation.
That's step 1.
And security is step 2. You can't let the web server talk to the database on just any port, and you certainly don't want the internet talking directly to the database.
Correct. You immediately apply an NSG to the DB subnet. That NSG must contain a high-priority inbound rule explicitly allowing traffic only from the web subnet IP range.
And only on the database port.
And only on the database port, which is often 1433 for SQL. All other inbound traffic is implicitly denied by the default rules.
And finally, resiliency. If the web server VM dies, we need a backup. And if the local hardware fails,
you place both the web VMs and the database VMs into separate availability sets. This ensures that even if Microsoft needs to perform scheduled maintenance, that's an update domain, or if a power supply fails, a fault domain within that data center.
Not all your application components fail at the same time.
Exactly.
Yeah.
Connecting these 3 elements, VNet, NSG, and availability set, that is the doer's mindset.
Principle number 2 is all about maximizing your speed and effectiveness in timed environments. Command line proficiency.
Look, the Azure portal is beautiful, but it is slow.
It can be, yeah.
When you hit a performance-based labs section of the exam, efficiency matters. Mastering either Azure CLI or PowerShell isn't optional, it's mandatory for speed.
You're saying you should be able to create a complex resource group and a storage account with specific redundancy and tiering policies in, what, 2 lines of code?
2 lines of code, significantly faster than clicking through multiple portal blades.
We're talking about instantly recognizing the structure of a storage account, create name my account resource group, RG web SKU, standard ZRS access tier.
Group.
Cool. That fluidity saves crucial minutes.
Precisely. And principle number 3 is perhaps the most fun, but the most instructional. Learn to break and fix things.
Administrators spend 80% of their time troubleshooting. If you only know how to deploy a working solution, you are only half an administrator.
You have to deliberately cause problems to understand the diagnostic tools. For example, deploy a VM, confirm RDP connectivity, and then immediately go to the NSG applied to its subnet and create a high priority rule, say priority 105, that denies all inbound traffic on port 3D389.
You just broke RDP access.
You just broke it.
And now we have to practice the fix using the right tool.
You don't guess. You don't delete the rule blindly. You practice using the Azure Diagnostic Suite, Network Watcher. You specifically use the IP Flow Verify tool, feeding it the source IP, destination IP, port 3389, and protocol TCP.
And it tells you exactly what's wrong.
Network Watcher will tell you traffic denied by security rule, deny all RDP, priority 105. This diagnostic loop is what solidifies your understanding of NSG rule priority and structure better than any training video.
Let's pivot to a deeper look at one of those key domains, storage, which is 15–20%. This is all about managing petabytes of data while keeping the costs under control. And the fundamental building block is the storage account.
The storage account is the primary unit of administration. Think of it as the top-level container defined in Azure Resource Manager, ARM.
Okay.
It provides 3 crucial things: a globally unique namespace, like youraccount.blob.core.windows.net, the security boundary, and the management container for all core services, blobs, files, queues, and tables.
And based on the documentation, we know which type should be the default choice.
Overwhelmingly, the focus for the modern administrator is the general-purpose V2 or GPv2 account. It is the modern recommended standard because it supports every redundancy option and every access tier.
So if an exam scenario doesn't specify some extreme performance requirements,
GPv2 is the answer.
but the administrator must know the exceptions. When does the complexity or cost of a specialized account become necessary?
You look at specialized accounts only when GPv2 performance is inadequate. For example, if you are running highly transactional financial services logs or a high-traffic gaming leaderboard, you might need a premium blob storage account.
Because they're faster.
They're optimized for consistently low latency and high transaction rates, using premium SSDs under the hood. Similarly, if you are migrating legacy file servers that require massive guaranteed I/O for enterprise applications, you must use premium file shares.
So why not just use the older, cheaper general-purpose V1? What is the technical risk there?
That's a great challenge. GPv1 is legacy. It doesn't support the cool, archive, or cold access tiers. If you deploy GPv1, you immediately lose all your options for aggressive cost savings through automated lifecycle management. The practical risk is inflated costs because all your data is stuck in the hot tier, even if it hasn't been touched in 3 years.
Resilience is the core trade-off calculation here. Let's dive into the redundancy options, revisiting that mnemonic we found in the strategic materials, L=Z1GEO.
This mnemonic is designed to anchor the resilience hierarchy. Least, more, most resilient. LRS, or locally redundant storage, is the baseline.
Okay, LRS.
It offers 3 copies of your data within a single data center. It is the lowest cost and, critically, offers 11 nines of durability, meaning the statistical chance of data loss is incredibly low, but it is vulnerable to a site-wide disaster.
So LRS protects against hardware failure. If we need protection against the data center going dark, we step up to ZRS.
Exactly. ZRS, Zone Redundant Storage, places 3 copies across 3 distinct availability zones within the same region.
And availability zones are separate buildings, right?
Physically separate buildings, each with independent power, cooling, and networking. This is the minimum recommended redundancy for any production, business, critical workload that requires regional high availability.
And when the entire region, say, due to a massive hurricane or seismic event, fails, that demands geo-redundancy.
That takes us into the disaster recovery space. GRS, geo-redundant storage, replicates your data asynchronously to a secondary paired region hundreds of miles away.
Okay.
By default, GRS uses LRS in both the primary and secondary regions. The ultimate most expensive option is GZRS, Geo-Zone Redundant Storage.
And how does that work?
It uses ZRS, that's data center level protection, in the primary region, and then replicates that data as LRS hardware level protection in the remote secondary region.
So an administrator chooses GZRS when the application demands maximum high availability within the primary market, plus non-negotiable disaster recovery far away.
Precisely. But here's the nuance that the exam loves. The read access options, RAGRS and RAGZRS.
What do those do?
These give you a read-only endpoint in the secondary region. The mission-critical scenario is a company has global reporting requirements and needs disaster recovery. They can leverage the RAGRS endpoint to run month-end analytics queries, offloading that read traffic entirely from the primary region.
So the primary application's performance is never impacted by heavy reporting needs.
That's the key.
Let's look at object storage structure. The administrator needs to know the difference between the three primary blob types before they can even start talking about cost optimization.
We have 3 key blob types. Block blobs are the default for general storage large files, backups, images. They are optimized for uploading and downloading large chunks of data.
Then we have append blobs.
Append blobs are specially optimized for continuous write operations, making them perfect for logging or auditing data where you are constantly adding new information to the end of a file.
Right.
Finally, page blobs are structured as a collection of 512 byte pages, and they are exclusively used by Azure to store the VHD files for managed disks.
Okay. Now, the money saver. Access tiers. How should an administrator think about the cost versus retrieval trade-off?
You have 4 tiers, and the cost profile shifts dramatically.
Start with hot.
Hot tier is for frequent, near-constant access. It has the highest monthly storage cost, but the lowest access cost and 0 retrieval latency.
Yeah, cool.
Cool tier is for infrequently accessed data requiring a minimum retention of 30 days. It offers lower storage costs, but slightly higher access costs. Think of data access maybe once a quarter.
The newer tier, cold.
Cold tier is the newest online tier, requiring 90 days of minimum retention. This is designed for data that must be instantly available. So, low latency, but is accessed very rarely, perhaps once a year.
So it's a middle ground.
It gives you substantially lower storage costs than Cool, making it a great middle ground for compliance data that still needs to be searched instantly.
And the deepest freeze? Archive.
Archive tier requires a 180-day minimum retention. It boasts the absolute lowest storage cost, but the retrieval cost is high, and the latency is measured in hours, not milliseconds. You have to wait for the data to rehydrate back to the hot or cool tiers before you can use it.
So that's for data you hope you never need.
Like 7-year regulatory backups, exactly.
When to manage all that data movement, we use lifecycle management.
Absolutely. Lifecycle management policies automate this cost optimization. You set rule-based policies that look at criteria like days since last modification or days since last access.
Can you give an example?
An administrator might set a rule. Any blob in the container logs that has not been accessed in 30 days must be moved to cool. After 180 days, delete it.
And that just runs automatically.
This policy runs daily and saves the organization from manually babysitting file age, ensuring compliance and maximizing savings.
Azure Files is the solution for classic file shares accessible via SMB NFS. This is the perfect lift and shift scenario for legacy applications that expect a network drive letter.
That's right. It provides the protocol that traditional applications understand. Just like block storage, Azure Files offers Standard, which is HDD-based, and Premium, which is SSD-based for higher performance and provisioned IOPS.
You raised a security alarm earlier regarding storage account access keys. If we're using Azure Files, why is using Enter ID authentication a non-negotiable best practice instead of relying on the key?
Because the storage account key is a security nightmare. If it's compromised, the entire storage account, all blobs, files, everything is compromised.
It's the root password, essentially.
It is. When you enable identity-based authentication, you join the storage account to Azure AD Domain Services or your on-premises Active Directory. This allows you to enforce granular file-level NTFS permissions.
So now a specific user can only access a specific folder.
Exactly. Your user, John Doe, can only access the finance folder because their AD identity grants them permission, not because they have the root key to the entire cloud.
And for businesses that aren't fully cloud native, the administrator needs to manage the hybrid bridge. That leads us to Azure File Sync.
Azure File Sync is the critical hybrid component. It maintains a centralized master copy of your data in an Azure file share while synchronizing it with local Windows servers. It keeps 4 components in sync.
Yeah, those.
The Storage Sync service, which is the Azure Management Plane resource, the Sync group, which defines the relationship between endpoints, the Cloud endpoint, which is the Azure file share, and the Server endpoint, the specific folder path on the local Windows server.
And the true value proposition that administrators love is cloud tiering. How does that feature function on the local server?
Cloud tiering is fantastic. It turns your expensive, limited local disk space into a massive cache.
How does it do that?
When files haven't been accessed in a specified time, say 60 days, FileSync moves the actual data up to the Azure file share. It leaves behind a pointer file locally called a reparse point.
So to the user, the file still looks like it's there.
The file icon looks slightly different, but the file path remains the same. When the user attempts to access the file, the reparse point triggers the immediate seamless recall of the data from Azure. This mechanism makes the local server feel like it has infinite capacity.
Let's transition to the networking domain. If storage is about capacity and cost, networking is about connectivity and security. Poor IP planning or weak traffic control here will ruin your deployment.
The virtual network, the VNet, is your private network in the cloud. It is scoped to a single Azure region, and the first rule of VNet planning is ensuring that all VNets that need to communicate via peering, for instance, use non-overlapping RFC 1918 address spaces.
You can't have 10.0.024 in 2 places.
You can't. It will break everything.
And subnetting is where the rubber meets the road for organization and isolation.
Subnetting is essential for 2 reasons: organization and creating dedicated homes for specific Azure services. For example, you absolutely must have a dedicated gateway subnet for VPN or express route connections and an Azure Bastion subnet for your Bastion host.
And here's the exam detail that everyone forgets, but it can sink a sizing question. Azure reserves 5 IP addresses in every subnet range.
That's right. For any given subnet, Azure reserves the first 4 IPs and the last IP address. They are used for network address, broadcast, Azure's internal router, and DNS mapping.
So if you define a 28 subnet, which technically has 16 addresses,
You only have 11 usable IPs. Knowing this detail separates the doer from the reader.
in terms of public IP addresses, why do we push the standard CU so hard, and what's the risk of using basic?
Standard is the modern production-grade choice. It is zone redundant, meaning the IP address itself is resilient to a data center failure within the region.
And it's more secure.
Crucially, the standard SKU is secure by default. It's closed to inbound traffic until you explicitly associate it with a firewall or network security group. Basic SKUs are exposed by default and lack that built-in resilience.
Let's clarify the security tools, starting with NSGs versus ASGs. They're often confused.
NSGs are the actual traffic cops. They are the stateful firewalls filtering based on that 5-tuple we mentioned. They decide whether traffic is allowed or denied based on priority rules, which are processed from the lowest number, which is the highest priority, upwards.
And ASGs.
Application security groups, ASGs, are simply tags. They are a logical way to reference a collection of VMs in an NSG rule.
Okay, so let me get this straight. Instead of writing an NSG rule that says allow 80 TCP from 10.1.1.1.1 10.1.111, I create an ASG called Web Front End and write the rule once.
Exactly. It dramatically simplifies management, especially as you scale. However, for centralized, organization-wide traffic security, you need to elevate to Azure Firewall. This is the key tool for securing egress traffic, preventing users from reaching malicious external sites, and providing F2DN filtering based on threat intelligence. It's the cornerstone of the hub-and-spoke architectural model.
That brings us to routing. When a packet tries to get to a VM in a secured environment, what is the exact inspection hierarchy it follows?
This sequence is critical for troubleshooting. The traffic hits the Azure firewall first if you have configured user-defined routes or UDRs to force that path.
Okay.
If UDRs send it past the firewall, it is inspected by the subnet NSG, applying broad subnet rules. If it survives that, it is inspected by the NIC NSG, applying rules specific to that VM.
So it's possible for traffic to be allowed by the subnet NSG, but then denied by the NIC NSG.
Absolutely. It's a common troubleshooting scenario.
UDRs sound like a lot of complexity. Couldn't a smaller company just skip them and rely on NSGs and the default Azure routing? Why is forcing traffic through the Azure firewall non-negotiable for high security?
That's a great challenge, and in a simple dev test environment, maybe you skip UDRs. But for enterprise security, UDRs are the only way to enforce compliance.
Oh, so
Azure's default routing sends all private traffic within the VNet and traffic destined for the internet directly out. If you don't use a UDR to say, hey, all internet-bound traffic from this subnet must go to the Azure firewall IP first, then users can potentially bypass your central security measures, downloading malware or exfiltrating data.
So UDRs ensure 100% traffic inspection.
Correct.
The era of exposing RDPSH ports to the public internet should be long dead. The modern, secure approach is Azure Bastion.
Azure Bastion is mandatory for secure remote access. It's a fully managed PaaS service deployed in your VNet that provides RDP or SSH connectivity directly from the Azure portal over a secure TLS connection.
And the key thing is the target VMs don't need public IPs.
Crucially, your target VMs do not need public IP addresses. Bastion connects to their private IP. This dramatically shrinks your attack surface.
To connect different VNets within Azure, we use peering. This is another area rife with exam traps. What are the two ironclad rules of peering?
Rule 1. Peering is non-transitive. If VNet A peers with B and B peers with C, A cannot communicate with C unless you specifically peer A and C. VNet B acts only as a connection point, not a router.
And rule 2.
You must have no overlapping IP address spaces. If you try to peer a VNet using 10.0.0.016 with one using 10.0.0.0.024, it will fail, and you cannot rename the VNet range once it's created. You have to delete and recreate the VNet.
For hybrid environments, administrators choose between two critical gateway types to connect back to the local data center.
We use virtual network gateways for that. The VPN gateway creates a site-to-site connection over the public internet using IPsec tunnels. It is cheaper and simpler, but relies on public network quality.
And the other option?
ExpressRoute provides a dedicated, private, guaranteed bandwidth connection through a physical provider, offering higher throughput and lower latency, but at a much higher cost and complexity. Both require that specific gateway subnet in the VNet.
And finally, name resolution. How do we make sure our app server can find the database server using a friendly name like sql.corp.local without setting up legacy Windows DNS servers?
That's the job of Azure Private DNS Zones. You create a private zone, say corp.local, and link that zone to your VNets. This allows VMs within those VNets to resolve records published in that zone, using Azure's native DNS resolution mechanism.
It's the simplest and most scalable way to handle internal naming.
In a cloud environment, yes.
For massive, highly complex deployments, especially those spanning multiple subscriptions, the standard NSG and UDR approach becomes unwieldy. That's why the administrator needs to understand Azure Virtual Network Manager, or VNM.
VNM is a key component for managing at scale, often seen in the 2025 updates. It centralizes control.
It does.
It does. VNM lets you centrally manage connectivity like mandating a mesh network across 30 VNets and, critically, centralized security. VNM allows central security teams to create security admin rules that override and enforce policies regardless of what NSG rules have been set at the subnet level.
Wait, so if I use VNM, those centralized security rules actually override my carefully crafted subnet NSGs. That changes everything for local team autonomy.
It absolutely does. It is the ultimate tool for corporate governance, ensuring no team can create a security vulnerability, even if they explicitly try to allow the traffic in their subnet NSG.
And when all this complexity inevitably leads to a connectivity issue, the administrator's best friend is Network Watcher. You must master this toolkit.
You have to.
We talked about IP Flow Verify earlier for diagnosing NSG blocks, but what are the other essential tools within Network Watcher?
There are two others that are crucial. First, NSG flow logs. This service records all traffic flowing through an NSG and sends that data to a storage account or log analytics workspace.
You get an audit trail.
You get the audit trail and the historical data you need to identify patterns of attack or intermittent failures. Second, Connection Troubleshoot, which is a comprehensive test tool.
How does that work?
You specify the source and destination, a VM, an FQDN, whatever, and it attempts to trace the path, diagnosing latency, routing problems, and firewalls issues all in one report.
I once spent 3 hours tracing a connectivity issue only to find the problem was a high-priority NSG deny rule added by a colleague who misspelled the port number as 8080 instead of 80.
Oh, no.
Network Watcher would have solved that in 60 seconds. That's the power of these tools.
It really is.
Now we tackle the remaining half of the exam, which, despite being grouped, covers the most heavily weighted topics. Compute at 20-25%, identity at 20-25%, and governance and monitoring combined at 25-30%.
We need to give these the attention they deserve.
Compute starts with the virtual machine. VM planning is highly structured. Meticulous naming conventions, location choices, proximity to customers for latency, or choosing a lower cost region. and locking down the most cost-effective pricing model.
Speaking of cost, if the workload is predicted to run 24/7 for the next year, what is the best cost mitigation strategy? You immediately leverage reserved instances, or RIs. By committing to a 1 or 3 year term, you can realize substantial discounts, often up to 60% compared to standard pay-as-you-go. This administrative action is crucial for budget compliance.
And powering those VMs are the disks. We default to managed disks, but the performance hierarchy is vital.
Managed disks are the modern standard. They abstract away the underlying storage accounts. The hierarchy runs standard HDD for lowest cost dev test only, standard SSD, and then premium SSD, which is the standard for production database servers requiring guaranteed IOPS.
And for even higher demand.
If you have specialized high-demand database applications, you look at Premium SSD V2 or Ultra Disk, which allow you to dynamically tune the IOPS and throughput without resizing the disk itself.
High availability is where the architect truly earns their keep. Let's fully distinguish between availability sets and availability zones as they protect against fundamentally different failures.
Availability sets provide intra-data center HA. They protect against local hardware failure and planned maintenance by spreading VMs across different fault domains, different power sources or racks and update domains, so VMs are updated in staggered groups.
So if one rack goes down, your service remains running on another rack within the same building.
Exactly.
Availability zones, however, solve a bigger problem.
Yes. Availability zones provide inter-data center HA. They distribute your VMs across physically separate, independent data centers within a region. If a catastrophic fire takes out an entire facility, your application running in Zone 2 and Zone 3 remains operational.
So for mission-critical apps today, availability zones are the best practice.
The higher-level choice, absolutely.
And for scaling out based on sudden demand, that's the job of VM scale sets.
VM scale sets, or VMSS, are the foundation of horizontal scaling. They deploy a uniform group of identical VMs. The administrator needs to know how to configure the auto-scaling rules, typically based on metrics like average CPU utilization.
So like if CPU goes above 75% for 10 minutes, scale out by 2 instances.
Precisely. And if it drops below 30% for 30 minutes, scale in by 1. They handle the creation, load balancing, and management of these identical instances seamlessly.
Identity, a massive 20-25% chunk of the exam, starts with disk encryption. We have 2 very different layers, server-side and guest OS.
SSE, or server-side encryption, is default on managed disks, where Azure encrypts data at rest for you. You typically use Microsoft Managed Keys or PMK.
But sometimes you need more control.
For specific regulatory compliance like HiPay or PCI, you may need Customer Managed Keys or CMK, using Azure Key Vault to control the encryption keys yourself, proving you are the sole controller of the encryption mechanism.
The other layer is ADE, Azure Disk Encryption.
ADE encrypts the VHD within the guest operating system, using BitLocker for Windows or dmcrypt for Linux. This ensuring that if the disk image were somehow copied and moved outside the Azure ecosystem, the data remains encrypted and unreadable.
So SSE protects the storage, ADE protects the data at the VM level.
That's a good way to put it.
Moving into Intra ID management, the administrator needs to know more than just user creation. What licenses impact critical features like self-service password reset, SSPR?
You need a clear understanding of licensing implications. While SSPR is automatically enabled for administrative roles, enabling it for standard users requires an Azure AD Premium P2 license.
And other features.
Similarly, implementing conditional access policies or advanced multi-factor authentication controls often push a view into P1 or P2 licenses. The administrator must connect the security requirement to the financial and licensing need.
Let's hammer home that authorization point for data plane access. We know the storage account access keys are too dangerous. So how does an administrator choose between RBAC and shared access signatures, or SAS?
Azure RBAC is the definitive long-term best practice for identities controlled by the organization users, service principals, managed identities. You assign roles like storage blob data contributor to an Intra ID group at the resource group or storage account scope. It's identity-driven.
When do you pivot to SAS?
You use shared access signatures, or SAS, when you need to grant temporary, fine-grained, delegated access to an untrusted external client, someone outside your Intra ID domain.
Like a third-party vendor.
Exactly. You want a vendor to upload files to a specific container for 30 minutes. You generate a SAS token, which is simply a URL parameter containing the security details. This token grants access only to that specific container for that duration, minimizing risk.
Governance is about setting the guardrails for your entire environment. Azure Policy is the organizational rulebook.
Azure Policy enforces compliance and consistency. The administrator needs to know the different effects of a policy definition. Audit, which logs non-compliance but allows the action.
Deny, which blocks the action.
And deploy if not exists, which automatically deploys a dependency, like a log analytics agent, if the user forgets it.
If a new policy is enforced, say, requiring all storage accounts to use ERS, what tool do you use to bring existing LRS accounts into compliance?
You run a remediation task. Azure Policy identifies the non-compliant resources, and the remediation task executes the defined deployment action, often using an ARM template, to modify those existing resources to meet the new compliance standard.
Now, cost management. Beyond reserved instances, what are the tools administrators use daily to keep budgets in line?
You rely on budgets and alerts within Azure Cost Management. You set a monthly limit and configure alerts to notify key stakeholders at 50%, 75%, and 100% of the threshold.
And you have to check Advisor.
You must also constantly review Azure Advisor recommendations, which will suggest things like shutting down idle VMs or downsizing underutilized resources.
We talked about RIs, but the other massive cost saver is Azure Hybrid Benefit.
Azure Hybrid Benefit, or AHAB, allows you to reuse your existing eligible Windows Server and SQL Server licenses with software assurance on Azure VMs, saving you the cost of the OS license in the cloud.
And when you pair those two?
Pairing RISE with AHAB can achieve total savings nearing 80% compared to standard PAG rates. Finally, administrators must know how to set up recurring cost data exports to a storage account, allowing finance teams to analyze spending patterns in external tools.
Infrastructure as code is mandatory for modern cloud administration. The exam focuses heavily on ARM templates and Bicep.
You need to understand the declarative nature of these tools. They define what the infrastructure should look like, not how to build it step by step.
And Bicep is just a cleaner way to write ARM templates.
Exactly. Bicep is the cleaner, more readable language that compiles down to the verbose JSON ARM template. The critical skill here is being able to take an existing deployment, export the ARM template via the portal, modify that template slightly, perhaps changing a VM size or a disk type, and redeploy it using the Azure CLI.
For data migration, especially when dealing with massive data sets where network latency makes ASCOPy impractical, administrators use a physical service.
That's the import-export service. ASCOPy is excellent for online transfers, using SAS or Entra ID authentication. But if you have 50 terabytes, you ship physical hard drives.
And the workflow for that is very specific.
The workflow is critical. You must first prepare the drives using the import-export tool on a local machine, which encrypts the data and generates a journal file. You upload that journal file to Azure, create the import job referencing the file, and then physically ship the prepared drives to the Azure data center. The journal file tells Azure exactly where the data goes and how to decrypt it.
Finally, platform services. When deploying web applications using App Service, the concept of deployment slots is key for zero downtime releases.
Deployment slots are essential. You deploy the new, untested version of your code to a non-production slot, like staging. Once testing is complete, you execute a slot swap. The new code instantly moves into the production slot, and the old code moves to staging.
But not everything swaps, right?
It's vital for the administrator to remember which settings travel with the swap. Things like application settings and connection strings are swapped. But key infrastructure settings, like the scale settings, IP restrictions, and custom domains, are not swapped. They remain bound to the slot itself.
This comprehensive deep dive has mapped the entire AZ-104 landscape, reinforcing the need for architectural thinking, layered security, and disciplined hands-on practice.
To condense everything we've covered into 4 non-negotiable takeaways for exam day success, internalize these points.
1. Cost optimization for storage.
Always default to general-purpose V2, GPv2, and leverage the cost-saving opportunities of the hot, cool, cold, and archive tiers aggressively, always automating movement with lifecycle management policies.
2. Network security layering.
If maximum security and private IP isolation from a VNet to a PaaS service is the mandate, you must choose a private endpoint over a service endpoint. This keeps traffic entirely within the Azure backbone.
3. Efficiency in labs.
Master the command line Azure CLI or PowerShell. Speed in performance-based labs is paramount, and familiarity with declarative syntax is the only way to finish on time.
And 4. Systematic troubleshooting.
When a connection fails, you don't guess the issue. You troubleshoot systematically using network watcher tools like IPFlow Verify to pinpoint the exact blocking NSG rule or connection troubleshoot for complex path tracing.
The knowledge we've covered today emphasizes that the AZ-104 exam tests decision-making, not recitation. The true measure of an Azure administrator isn't whether they can create a resource, but whether they can immediately diagnose why a connection is failing or why the bill is so high. You're now equipped with the knowledge of common pitfalls, whether that's overlapping IP spaces in peering, forgetting NSG rule priority, or not having the right redundancy for your mission-critical data. Based on the material we covered today, what single point of failure are you going to proactively eliminate from your next production deployment? That's the question that defines the Azure doer's mindset.